In this video, we'll find the divergence and the curl of a given vector field. So our function, or our vector field, f of x, y, z, is x, y squared, z squared, x squared, y, z squared, and x squared, y squared, z. Let's find the divergence first. The way you can do this is basically, it's written like this, div, and then f, and that's going to be equal to del capital F, del dot capital F. So the way you do this, this is important, by the way, this is what you're trying to use, or you're going to use. And so let's go ahead and solve the problem. Now del is equal to the partial with respect to x, partial with respect to y, partial with respect to z. And then f, we have it up there. I'm not going to write it again. That's what f is. Now, if you want to build this here, this is basically equal to partial with respect to x, partial with respect to y, and partial with respect to z. Now, what I'll do is instead of writing dot dot dot, something that's better is naming these. So I'll name this P, I'll name this Q, and I'll name this R. And so here, instead of dot dot dot, which is kind of messy, this is P, this is Q, and this is R. The reason why is because now I can just do dot P, Q, R. And then div f is, so basically we take this and we multiply that with this, and then this with this, this with this, and we add them together. Okay, let's do that. So partial with respect to x. Now what we do is we have partial with respect to x, p, and the way you can write this is just partial p, partial x, and we add that with partial q, partial y, and then plus partial r, partial c. This is actually the formula. Now, if you don't want to build it up like I did, which actually I would recommend doing instead of memorizing a formula because it's not gonna stay long term, is I just memorize this formula here. If you want to memorize a formula, but honestly, it's not that hard to build it up. Just remember this formula, and that you should probably remember, and then you can get to this point quite easily if you understand what these parts are. Now let's find each of them individually. It's not that time consuming. This is basically looking at this here and treating y and z as constant. So it's y squared, z squared. Then the partial q, partial y is treating z, x and z is looking at this here. X and z is a constant, x squared, z squared. Partial r, partial z is this one. It's just x squared, y squared. Add them all together, we end up with div f is y squared, z squared plus x squared, z squared plus x squared, y squared. Does the order matter? No. You can switch up the order, it's fine. This is the divergence. And this is just a formula for this specific vector field. You can plug in different points to get the divergence at that point on this vector field. And so, for example, a point would be 0, 0, 0. There's so many different points you can choose from that you can plug in based on your problem. Can I simplify this anymore? Can I factor something out? Can I do anything of that sort? Not really, because what's in two of these is not in the third, and so on and so forth. So you can't really factor anything out of the whole expression necessarily. So it's not really too helpful to factor out of two expressions and leave the last one alone. So it's not too helpful to do anything. And this is probably a good way to leave our solution. Next, let's find the curl. The curl of f is del cross f. That's it. That's basically it. That's the formula. So del, same thing, is partial with respect to x, partial with respect to y, with respect to z. And actually, let me not write this out because I already wrote it out before. Let me actually just set up the formula straight up. So the way that people write this is like this. So curl f is equal to I, j, k. You can add the hats on top of these if you want. And then here you do partial x, partial y, partial z, and then here you do the f, p, q, and r. So p, q, and r. P, we have it here. Actually, we have to scroll up. P, we have it up here. So x, y squared, z squared. I'm writing this here. You can't see, so but once I write it, you'll see. So x, y squared, z squared, x squared, y, z squared, and x squared, y squared, z. Okay. X squared, y squared, z. Here is your, here's what you need to write. And you want to find the determinant. So basically what you do is you just ignore, well, not ignore, but you just draw a line, two lines, across like this. And basically you draw the lines where the I is located at. And then you don't have to draw the line, you can draw a line in your head. But then what you do is you use only these. And then you find the determinant. So the way that's going to happen is just partial y, x squared, y squared, z. Minus minus. Let's evaluate this. So that's going to be x squared z minus 2, sorry, this is not x squared z. This is 2x squared z minus 2 x squared z I minus 2xy squared z minus x 2xy squared z j plus 2xyz squared minus 2xyz squared. Okay. Remember when you're doing the determinant that the first one's going to be I, and then minus, and then this, and then plus that. That minus is important. Here, though, it doesn't really matter. It's just 0I minus 0j plus 0k. So really, that's, just we can think about as 0, 0, 0, which is the 0 vector.